Venus, the brightest planet in our night sky. A glowing beacon that appears just before sunrise or just after sunset, shining so brilliantly that for thousands of years, ancient civilizations saw it as a symbol of beauty and mystery. But behind that glow lies one of the most hostile worlds in the entire solar system. A planet where the surface is hot enough to melt metal, where the air is dense enough to crush you, and where stepping outside would mean instant death. This is Venus, and it wasn't always this way. At first glance, Venus seems almost identical to Earth, nearly the same size with similar mass, density, and internal structure, making it what scientists often call Earth's twin. Two planets formed from the same cosmic material, in the same region, around the same star, yet their fates turned out completely different, because while Earth became a world filled with life, with oceans, clouds, and stable temperatures, Venus became something else entirely, a world with no water, no life, and no escape from its extreme conditions. Today, the average temperature on Venus is around 870 degrees Fahrenheit, hot enough to melt lead, making it even hotter than Mercury, despite Mercury being closer to the Sun, a fact that seems almost impossible at first. And the heat is only part of the story, because the atmosphere of Venus is so thick that the pressure on its surface is more than 90 times that of Earth, meaning that standing there would feel like being deep underwater, except instead of water, you are surrounded by a suffocating blanket of toxic gas, while above you, clouds of sulfuric acid stretch endlessly across the sky. No human has ever stepped foot on Venus, and even our most advanced spacecraft have only survived there for a short time, before being destroyed by the extreme pressure and heat. So the question becomes unavoidable. How did a planet so similar to Earth turn into the most hellish world in the solar system? Because the truth is, Venus may not have always been like this. There was a time, billions of years ago, when it could have looked very different. A time when it might have had oceans, clouds, and possibly the basic ingredients for life. But something changed. Something triggered a chain reaction that transformed this world beyond recognition. And to understand what went wrong, we have to go back to the beginning. Billions of years ago, in the early days of the solar system, Venus may have been a completely different world. Not the burning wasteland we see today, but a planet that could have looked surprisingly similar to Earth, because when Venus first formed, it had many of the same ingredients that make a planet potentially habitable: a solid surface, a thick atmosphere, and most importantly, it may have had water, vast amounts of it. Scientists believe that early Venus could have supported shallow oceans with liquid water, covering parts of its surface for millions or even billions of years, creating conditions where basic chemical processes might have taken place, the same kinds of processes that eventually led to life on Earth. And this idea is supported by computer models and data from past missions, suggesting that Venus once had a much cooler and more stable climate with clouds that may have reflected sunlight and helped regulate temperatures, keeping the planet in balance. But there was one critical difference, one small detail that would slowly change everything. Venus orbits closer to the Sun than Earth, receiving significantly more solar energy. And at first, this extra heat may not have seemed like a major problem. The planet may have maintained a delicate balance between incoming heat and the energy, escaping back into space. But over time, that balance began to shift. As more solar energy reached the surface, temperatures slowly started to rise, and as the planet warmed, something crucial began to happen. Any existing oceans would have started to evaporate, releasing water vapor into the atmosphere. And water vapor is a powerful greenhouse gas. It traps heat very efficiently, preventing it from escaping into space. This caused temperatures to rise even further, which led to even more evaporation, adding more water vapor into the atmosphere. strengthening the heat-trapping effect. A feedback loop had begun, one that continued to grow stronger over time, and as this cycle continued, Venus moved closer to a tipping point, a moment where the planet would no longer be able to cool itself down, no matter what happened next. Once that threshold was crossed, the transformation became unstoppable. The oceans continued to vanish, the atmosphere grew thicker and hotter, and Venus began its irreversible shift into something far more extreme, a process that would soon lead to one of the most destructive climate events a planet can experience. And as the temperature kept rising, Venus was no longer just warming, it was heading toward a complete planetary breakdown. As temperatures on Venus continued to rise, the planet crossed a critical threshold, triggering one of the most destructive processes in planetary science, the runaway greenhouse effect. A chain reaction so powerful that once it begins, it cannot be stopped. What started as gradual warming quickly turned into a self-sustaining cycle. As more water evaporated from the surface, the atmosphere filled with thick layers of water vapor, trapping heat more efficiently than ever before, preventing it from escaping into space. This trapped heat pushed temperatures even higher, causing even more water to evaporate, feeding the cycle again and again, faster and more intensely over time. Eventually, any oceans that may have existed on Venus completely disappeared, not frozen or absorbed, but lost into the atmosphere itself. And as the upper atmosphere was exposed to intense solar radiation, another dramatic process began. Ultraviolet light from the sun started breaking apart water molecules into hydrogen and oxygen. And because hydrogen is extremely light, it escaped into space, drifting away forever, while the heavier oxygen either reacted with surface materials or was gradually lost as well. Over time, Venus wasn't just losing its oceans, it was losing the very elements needed to ever form them again. With water gone, the planet lost one of its most important cooling systems, leaving the surface fully exposed to the growing greenhouse effect. At the same time, volcanic activity released massive amounts of carbon dioxide into the atmosphere, a gas that is extremely effective at trapping heat, and without oceans to absorb it, that carbon dioxide built up rapidly, forming a dense, suffocating layer around the planet. Temperatures continued to climb until the environment reached a point where it no longer mattered whether it was day or night. The heat had become constant, locked in place by the thick atmosphere. What once may have been a balanced world had now crossed the point of no return. Every natural system that could have stabilized the climate had failed. And this is what makes the runaway greenhouse effect so dangerous. It doesn't just warm a planet, it permanently changes its future. By the time this process was complete, Venus was no longer a potential twin of Earth. It had become a world, trapped in extreme heat with a surface that baked under crushing pressure and an atmosphere that would make survival impossible, setting the stage for the hellish environment that defines the planet today. Venus is surrounded by an atmosphere so extreme that it defines every aspect of the planet, turning it into a place where survival is impossible. This atmosphere is made up of about 96% carbon dioxide, forming a dense, heat-trapping blanket around the planet, with thick clouds of sulfuric acid suspended high above, creating a reflective layer that locks heat in with brutal efficiency from space. These clouds appear smooth and almost calm, a pale yellow glow covering the entire planet. But beneath that surface lies an environment of constant pressure and chemical intensity. As you move deeper into the atmosphere, the pressure increases rapidly until reaching the surface, where it becomes more than 90 times stronger than Earth's, enough to crush most spacecraft within a short time, ending missions almost as soon as they begin. But pressure is only part of the danger, because the atmosphere itself is highly toxic. filled with gases. That would make breathing impossible. While the sulfuric acid clouds above create a cycle of corrosive droplets that form and evaporate before ever reaching the ground. Due to the extreme heat below, the result is a sky that never clears. An endless layer of thick haze that blocks direct sunlight, reducing the sun to a faint glow behind the clouds. Despite this, the upper atmosphere is incredibly dynamic, with powerful winds racing around the planet, at speeds reaching hundreds of miles per hour, completing a full rotation in just a few days, a phenomenon known as superrotation, where the atmosphere moves much faster than the planet itself. Yet near the surface, everything feels strangely still, with slow-moving winds and an almost silent environment, as if the entire world is trapped under a heavy, unmoving weight. Visibility is limited, the horizon blurred by dense air, and the color of the sky shifts into deep shades of orange and yellow, creating a constant, dimly lit landscape. Every second in this environment would be overwhelming, as heat, pressure, and toxic gases combine into a system that pushes everything beyond its limits. This is not just an atmosphere, it is the final result of everything that went wrong on Venus, a system that traps heat, crushes anything that enters it, and isolates the surface from the rest of the universe. And beneath this suffocating sky lies a world just as extreme, a surface shaped by volcanic force and time, where the true nature of Venus becomes even more clear. Beneath the thick cloud cover of Venus lies a surface that feels frozen in time, a vast and desolate landscape shaped by fire, pressure, and extreme heat. Where nothing moves and nothing survives, the ground is covered in endless volcanic plains, with hardened lava flows stretching for miles, evidence of a past defined by intense geological activity. Venus is believed to have thousands of volcanoes, some far larger than any found on Earth, making it one of the most volcanically active worlds in the solar system. But unlike Earth, where tectonic plates constantly shift and recycle the surface, Venus appears to have a single, unbroken crust, trapping heat beneath it, until it is suddenly released through massive eruptions, events that may have resurfaced the entire planet. In the distant past, this has created a landscape that looks both ancient and uniform, as if it has been melted and reshaped over and over again, leaving behind a terrain that is harsh, cracked, and completely lifeless. Yet the strangeness of Venus goes beyond its surface, because the planet itself behaves in unexpected ways, rotating in the opposite direction of most planets, a phenomenon known as retrograde rotation, where the sun would rise in the west and set in the east, and even more unusual is how slowly it spins, taking longer to rotate once than it does to orbit the sun, meaning that a single day on Venus lasts longer than its entire year. Despite this slow rotation, the temperature across the planet remains nearly constant, with no real difference between day and night, because the thick atmosphere traps heat so efficiently that cooling is almost impossible. Everything about this world, from its burning surface to its silent, motionless skies, reflects a planet pushed beyond its limits, where natural systems no longer function the way they should. And as we begin to understand just how extreme Venus has become, a deeper realization starts to take shape, because this is not just a distant world with unusual conditions, it is the result of a process that transformed an entire planet, showing what can happen when balance is lost completely. Venus is not just another planet drifting through space, it is a warning written across an entire world, a reminder of how powerful and fragile planetary systems can be. When scientists study Venus, they are not only trying to understand its past, they are also looking at a possible version of Earth's future, because the same physical laws that shaped Venus still apply here. On Earth, the greenhouse effect plays a critical role, trapping enough heat to keep the planet warm and habitable. But like Venus, that balance can change. Earth has natural systems that help regulate its climate, oceans that absorb carbon dioxide, and ecosystems that maintain stability. But these systems are not unlimited. Venus may have once had similar conditions, with oceans and a more balanced atmosphere, but once those systems began to fail, the planet crossed a tipping point where recovery was no longer possible. A runaway process took over, removing any chance of restoring balance and transforming the planet into an extreme, uninhabitable world. This is what makes Venus so important, not just as a subject of curiosity, but as a comparison, showing how small changes over long periods of time can lead to massive and permanent consequences, while Earth is not on the path to becoming Venus. The example highlights how sensitive planetary environments can be and how quickly they can shift when critical limits are reached. Venus shows what happens when heat becomes trapped beyond escape, when cooling systems fail, and when balance is replaced by extremes. Yet Earth still has something Venus no longer does: the ability to maintain that balance, and the presence of life that interacts with its environment. In the end, Venus is more than the brightest object in our sky after the Moon. It is a story of transformation, a world that may have once been familiar, but is now completely alien. Where oceans disappeared, the atmosphere turned toxic, and the surface became a furnace. And as we look at Venus today, shining in the distance, it stands as a reminder that even planets that start out similar can end in completely different ways, because sometimes the most distant worlds reveal the most important truths about our own.